Hello and Assalamualaikum. This is video on acid, base and salt on subtopic 6.9 preparation of salts. Okay, so to choose a method to prepare a salt, we have to know first the solubility of salt in water. Okay, so this table shows the type of salt and the solubility of salt in water. So the method to determine whether the salt is soluble or insoluble is very easy. You just take a beaker, then you fill with half beaker with water, and then add some salt, and then stir. Then you can check if the salt is soluble or insoluble. Okay, so based on this table, if you can see here, nitrate salt. All nitrate salt are soluble. Okay, so all nitrate salt are soluble. So what are example of nitrate salt? Example of nitrate salt is sodium nitrate, potassium nitrate, magnesium nitrate, zinc nitrate. All are nitrate salt. Okay, second, sulfate salt. All sulfate salt soluble except lead to sulfate, barium sulfate, and calcium sulfate. Or you can simplify it as BACA. Okay, chloride salt. All chloride salt soluble except mercury chloride, lead to chloride, silver chloride, or PAH. Lead 2 chloride, silver chloride, and mercury 1 chloride. Carbonate salt. Okay, so for the carbonate salt, almost all carbonate salt are insoluble except this. This is SPA, sodium carbonate, potassium carbonate, ammonium carbonate salt. Okay, only 3 carbonate salt soluble in water. And all ammonium, sodium, and potassium salt are soluble in water. We can use this mnemonic to memorize the solubility of salt in water. Okay. Okay, based on the solubility of salt, we have different method to prepare salt. Okay. So first we have to determine whether the salt is soluble or insoluble. Okay, next is we identify if the salt, let's say the soluble salt, if the salt is sparse salt, or just now they use asap, sparse salt or not sparse salt. Sparse stands for ammonium, sodium, and potassium. Okay, S is sodium, P potassium, A ammonium. Okay, so to prepare sparse salt, we use the reaction between acid and alkali. Only this one reaction, acid and alkali. Okay, for soluble salt, still soluble salt, but not sodium, potassium, or ammonium salt. Okay, so we can choose either these three. We can choose one. Acid plus reactive metal, acid plus metal oxide, and acid plus carbonate metal. Okay, so all this will produce a soluble salt. Okay, and next, insoluble salt. Only one reaction produce insoluble salt, which is precipitation reaction or double decomposition reaction. Double decomposition reaction means you add 2 different types of salt to produce one soluble salt and another one is soluble salt. Okay, so first, to prepare a salt, first you have to know whether the salt is soluble salt or insoluble salt. And then you have to identify whether the salt is sparse or not sparse. Okay. Okay, this is the method to prepare soluble salt for sparse, for sodium, potassium, and ammonium salt. Okay, asap. Okay, ammonium, sodium, potassium salt. Okay. For example, ammonium chloride, sodium sulfate, potassium nitrate. Okay, all this salt is prepared by this method. Okay, first is you add acid and alkali. Okay, after reach the end point. Okay, after reach the end point, then you get soluble salt here. But the soluble salt is mixed with water. Because reaction between, let's say here, hydrochloric acid and potassium hydroxide will produce potassium chloride and water. And this salt soluble in water. So inside this is salt solution. Means we have potassium chloride and water. So how do we separate water and the salt? Okay, so by this method, you heat the salt until saturated. Until saturated means about 1/3 of initial volume of the salt. Okay, and then stop heating, let it cool, and then you rinse the salt here, and then filter the salt between two filter paper. Sorry, not filter, dry the salt between two filter papers, and then you got solid salt, soluble salt, but the water is no more. There's no more water now. Okay, this one is preparation of soluble salt, but not spa. Not spa, not asap. Not spa or not asap. Any one you can use. Okay, ammonium, sodium, and potassium. Okay, so this is also a soluble salt. So the method you can choose, the reagent you can choose is acid. You must use acid. Whether acid and metal, reactive metal, acid and oxide metal, or acid and carbonate metal. So in this example, they use oxide metal and acid. So if you use copper to oxide and nitric acid, finally you will produce copper to nitrate salt. This is copper to nitrate salt. Okay, so acid, you put it in a beaker. Okay, and then add solid copper to oxide bit by bit, and stir it until there is, how do you know it is excess? Until the black solid of copper to oxide is no longer dissolved. You will see the black solid inside the solution. And then after no longer dissolved, you filter to eliminate the excess copper to oxide. So you filter. So excess copper to oxide will be in the filter paper, filter funnel. You have your salt here now, but your salt still is salt solution, so it has water. And then you heat the salt until saturated, and then you filter and rinse, and then dry the salt between two filter paper. Okay, and then you got the salt. Okay, this is purification of soluble salt by the recrystallization method. Okay, let's say here you have copper to sulfate salt. Okay, you put it in half beaker of water, and then stir until all the crystal dissolve. Next is you filter the salt solution. Here is the filtrate, and the excess insoluble impurities will be left out in the filter paper. Okay, and then heat the salt solution until saturated, and again you repeat the same step. Rinse the salt and dry the salt between two filter paper. Actually, you just memorize the keyword. Filter. So the first method is now start from here. You have the salt solution. You filter the salt solution, and then heat and until saturated. and then rinse, and the last one is dry. Okay, only 5, 1, 2, 3, 4, 5 method. FHSRD. Okay. Okay, this one is preparing insoluble salt by double decomposition reaction. So means you want to prepare insoluble salt. Okay, so you have to use two different soluble salt. Let's say you want to, okay, if here they use barium chloride and sodium sulfate, means they want to produce barium chloride and sodium sulfate. Means the salt produced is barium sulfate and sodium chloride. Sodium chloride is always a soluble salt. Okay. So the insoluble salt we want to produce now is barium sulfate. So this dry insoluble salt is barium sulfate. So you add two different salt here. Insoluble salt, barium chloride salt, and sodium sulfate solution. You add immediately when you add these two salt, it will produce a precipitate. Okay, so the precipitate is actually barium sulfate. So next, what you have to do is you just filter the mixture. You don't say filter the solution because precipitate is not solution. You don't say you filter the precipitate, but you filter the mixture. These two substances, the mixture. And after you filter the filtrate here, this filtrate is sodium chloride, and the residue here is barium sulfate. Okay, and then you rinse. Here, rinse. Because maybe on the barium sulfate it still has sodium chloride. Okay, that mean then you rinse. After you rinse, you dry the insoluble salt by pressing it between two filter papers. Okay, so this is construction of ionic equation through the continuous variation method. This continuous variation method is used to construct the ionic equation for the formation of insoluble salt. Okay, so in this method, the volume of one solution, let's say solution A, is fixed. Here, the solution A. So fixed, the volume is fixed. Maybe you use a 5 cm³ of solution A. Okay, so you put in all 8 test tube. We use 8 test tube. Okay, and then another solution, let's say solution B. Solution B is added to the solution A by increasing the volume as shown here. Okay, in test tube 1, we use 1 cm³, test tube 2, 2 cm³, test tube 3, and until test tube 8. Okay, 8 cm³. And then what happened? What is our observation? Okay, after half an hour, we add the two solution. So we will see the observation like this. Okay, the height of the precipitate form increases gradually from the first test tube and then until it become constant. Started from any test tube lah. As here shown here is on test tube 5, constant. Okay, so next is you calculate the number of mole for both reagent in this test tube 5. Why? Because the height of precipitate start constant from this test tube. Means in this test tube the reaction is complete. The ratio of both reagent is the right ratio. Okay. Okay, so for this one, this is lead to ion and iodide ion. For this one, after we determine the number of mole, then we find the ratio of these two ion, and you got the value of X and Y. Okay, so through the experiment, we can construct ionic equation through this method, continuous variation method. So we construct means we construct this ionic equation through an experiment that we call it continuous variation method. Okay, so that's all for today. Thank you for joining me. See you on my next video. Bye.